Up to this point, we've covered various analytics that run directly on the cameras, with the NVR receiving event notifications and allowing us to search those events. The main exception is face recognition, where the recognition process is performed on the NVR itself, based on snapshots sent by the camera. In addition, the NVR can also run certain analytics on its own hardware using an internal AI engine that supports a limited number of channels. This capability is intended for cameras that do not support analytics natively, including basic cameras or third-party models where the communication protocol is not sufficient to transmit analytics events. In these scenarios, the camera provides only the video stream, and the NVR handles the analytics processing. There are two types of analytics that the NVR can perform directly on its own hardware: face recognition and cross-line or sterile area detection. The NVR can support a higher number of face recognition channels when face detection is performed on the camera rather than on the NVR itself. In this scenario, the camera handles the detection and sends snapshots to the NVR for recognition, which significantly reduces the processing load on the NVR. Let's see how the NVR's internal onboard AI engine works in practice. In this example, our NVR has two connected cameras that are not Provision-ISR cameras. One is a Hikvision camera, and the other is a generic ONIV third-party camera. When we open perimeter monitoring, we can see that initially no onboard AI resources are being used by the NVR. Once we enable line crossing detection by NVR on the Hikvision camera, which is a third-party device, the NVR immediately allocates 50% of its onboard AI capacity. This means this specific NVR model can support onboard analytics for only two third-party cameras. If we then enable analytics on the ONIV camera, either line crossing or face detection and recognition, the remaining 50% of the AI resources are consumed, bringing the NVR to its maximum onboard analytics capacity. In this scenario, face recognition includes both face detection and recognition, since the camera itself does not support detection. The recognition process follows the same workflow we covered in previous tutorials. If we disable these analytics, the NVR releases the resources and the corresponding checkboxes are automatically cleared. Now let's compare this with a camera that supports on-camera face detection. When we enable face detection on a PTZ camera that performs detection on board, no NVR AI resources are consumed because the NVR is not processing the detection itself. Only when we enable face recognition on the NVR do we see resource usage, specifically 16%, exactly as demonstrated in the face recognition tutorial. If we then combine this with a third-party camera, such as the Hikvision camera, and enable face detection and recognition on that camera, the total NVR resource usage increases to approximately 67%. At this point, attempting to enable additional onboard analytics will be blocked, and the NVR will indicate that no further capacity is available. There is an Excel planning file available from our support team that helps calculate different deployment scenarios based on the NVR model and its onboard analytics capacity. For example, a 4-channel NVR can support 2 channels of sterile area or cross-line DDA1 analytics. A 16-channel NVR can support either 2 channels of DDA1 analytics, 2 channels of face detection and recognition, or a mixed setup with 1 channel of DDA1 and 1 channel of face recognition. A 128-channel NVR can support either 4 channels of face recognition performed on the NVR or 16 channels of face recognition when face detection is done on the cameras. This Excel file makes it easier to plan capacity and choose the right balance between on-camera and on-board analytics. For each NVR model, you can find a dedicated datasheet on the Provision-ISR website. In the Analytics section of the datasheet, you can clearly see which analytics are supported, including the available options for onboard NVR-based analytics.